Who wants to check out a Filecoin demo?
All right, that is very loud. I thought that I would give you a Filecoin demo manually, but I have the next best thing, which is me plus a lot of hours of like compressing down into a really good demo. So I'm going to preview demos that are going to go out. So instead of one demo, I'm going to give you 3 demos, and I'm going to play them for you. So they're going to be a video. And then after that, I'm going to answer any questions you have. Sound good? And then I can like actually run it here if you want. But I think that the video recordings are going to be better. So we're going to see 4 demos.
In this demo, we'll show a local test network.
Can we try it once more?
In this demo, we'll show a local test network with many Filecoin nodes and a simulator issuing a number of actions randomly. To run this, we'll use Go Filecoin and a testnet simulator tool. Note, everything we are showing here is still in development and very much subject to change, especially the naming or arranging of commands. On the right, we can see the help text of the Go Filecoin program. On the left, we can see the help text of our testnet simulator. This is a program that creates a network, adds Filecoin nodes with a role, miner or client, and then automatically runs through many kinds of actions, sending payments, adding market orders, and storing files. We can configure the simulator to set the size of the network, block times and other durations, the actions to issue, and more. It allows other test programs to issue commands and even manual user input. It's useful for debugging, for testing, and for demoing Filecoin. Let's run it with default settings. It outputs some links, its configuration, and starts up. It is now spawning Filecoin nodes according to configuration and issuing commands to run randomly chosen actions. Below, we can see the Go Filecoin processes running on this computer. Go Filecoin daemons are the individual nodes. The ephemeral Go Filecoin processes issue commands to the nodes. The message wait command is used to wait until a particular transaction is mined into a block. The logs endpoint aggregates the event logs of all the Filecoin nodes in the network. This is all the activity in the network. We can filter it with familiar tools like grep and JQ. And we can use it to drive visualizations. More on that later. We can also inspect the running Filecoin processes and issue commands to each of the nodes manually. Let's try one out. We can get information about the node, like the peer-to-peer connections, its wallet address and bounds, the blockchain as it sees it, the order book, the message pool, and so on. We can also send transactions manually, which we'll see in other demos. Quitting the simulator will shut down all the Filecoin nodes cleanly. The local repositories are left in temporary directories so that its internal data and its logs can be inspected manually. This is useful for continuous integration tests and debugging. Okay, I want to show you something very exciting. Let's restart the simulator. Now let's open a visualization of the network. This tool is consuming the aggregated logs and rendering animations for a subset of the events real time as they come in. We are seeing exactly what's happening live in the network. Let's go over what's going on. We can see miner and client nodes joining the network every few seconds. We can see blocks being mined and propagated to the rest of the network. The block time here is accelerated to 3 seconds. We can see a listing of the current longest chain here. We can see payment transactions where one party sends Filecoin to another. We can see asks and bids being added to the storage market. We can see a listing of the order book and even a depth chart. Now, the most exciting part, once asks and bids overlap in the market, deals start happening. Clients and miners match up, make and sign a deal, and the client transfers the file to the miner. These nodes are storing real files. We can also see a listing of the nodes below, along with what they see in the network. The chain head changes as the node mines or receives a new best block. So you can see nodes mining new blocks, propagating them, and the network reaching consensus. This visualization just renders logs, so it can be replayed at any point from a captured trace of events, which makes it useful for debugging. And one more thing. If we click one of the nodes, we get to see a basic Filecoin chain explorer from the perspective of that node. Here's the chain coming in live. We can see the details of a block, the hash, the miner, the parent block, and all the messages and transactions. We can see the method invocation and serialized parameters. These are invocations to an actor. These are payment transactions. Over here, we can also see all running actors in the system and inspect their local storage. For example, individual accounts with their balance, miner accounts with their pledge details, and even system actors like the storage market, which holds the asks, bids, and deals that make it on-chain. These visualizations are far from perfect. They're mostly tools for developers, but it is also exciting to see the network real time and see everything that's going on. It's cool to see the market order book, deals being formed, and files being transferred. You're seeing the first decentralized storage market coming to life.
In this demo, we'll show the basics of the storage market. The commands and interfaces shown here. I'm already started. Can we bump up the volume? In this demo, we'll show the basics of the storage market. Is the volume there? I'm going to start it again. The commands and interfaces shown here will change significantly as we implement the protocol and flesh out features. Can you bump it up a little more? First, let's start a local testnet with a few nodes. I'm going to start it again. In this demo, we'll show the basics of the storage market. The commands and interfaces shown here will change significantly as we implement the protocol and flesh out features. First, let's start a local testnet with a few nodes. We'll disable client market actions so that we can see just our activity. The miners in the network are mining blocks and adding storage market asks. We can see the network in the visualization, including the storage market starting to fill with asks. In the top terminal, we'll start sending commands to one of the miners through its API. Let's add an ask to the market, which tells the market that this miner is willing to store data at a particular price. Asks also include a duration of time, but this is not ready to demo yet. Let's set a price lower than everybody else in the market. This way, we'll get the business. Our ask will show once the next block is mined. There it is. Now, let's make a client store some files. Once the bid is in the chain, it locks funds from the client. Now let's hire the miner. To propose a deal, we need the IDs of the asks and bids. We can inspect the live asks and bids with the order book command. Here are the asks, and here's a single bid in the market. Of course, there are no deals yet. We import the file we want to store. This calls IPFS importing under the hood, so it will chunk files automatically. For those of you familiar with IPLD, both the files in Filecoin and the entire blockchain are structured as IPLD. The proposed deal command does several things. It finds the miner who created the ask in question. It sets up a direct connection to them. and it sends a deal proposal from the client to the miner, which references the ask, the bid, and the data to store. The miner receives the deal and considers it. The miner can reject the deal if the asks and bids don't match, if the miner's asking price has changed, or if the miner simply wants to refuse this client or this deal in particular. It's an open market, and the client should go find some other miner. If the miner accepts the deal, it lets the client know, and the client schedules the transfer of the relevant data. If the data is small and can be easily sent over the internet, 10 gigabytes scale or less, the client just sends the data over the protocol. If the data is too big to send over the internet easily, think many terabytes, petabytes, or higher, the miner and client can arrange a separate data transport over much higher bandwidth links, such as packet switching, shipping containers, or station wagons loaded with tapes speeding down highways. Note that the transfer of data is completely verifiable, and the miner will only accept data that matches the deal. Once the miner has received all the data, it signs the deal and returns it to the client. The miner or the client can post the deal to the blockchain to finalize the transaction. By default, the miner does it, but the client is able to do it as well. This covers an important protocol edge case. Once the deal is on the blockchain, the miner is responsible for storing the data and will be tested on it periodically. This sounds like a lot, but in the general good behavior case, it happens very quickly. In this demo, the miner will accept the deal automatically, and the data transfers immediately. Watch the visualization. When I press enter, the deal will trigger and the file transfer will happen. All right. At this point, the miner and client have struck a deal which is logged in the storage market order book. We can see it both in the visualization and in the command line. Finally, let's see another client retrieving the file. Let's grab a node we haven't used yet. Let's find the data referenced in the deal, and let's download the file using the client cat command. This finds and retrieves the file from the storage miner. We can diff the new file against the original to show they have the exact same contents. Now, let's check out what we stored and downloaded. Some final notes. The retrieval market is not in this demo, as it is still a work in progress, but conceptually, it will function similarly to the storage market. In the future, market orders, asks, bids, and deals don't have to happen through the blockchain. We have working designs for running markets entirely off-chain using payment channels. All right. All right, questions? Yep.
If someone posts a bid or ask, I assume they have to pay some kind of like gas fee to post that. If they want to then adjust it, do they then have to pay like another transaction fee for that posting?
So this is two answers. One answer is on-chain and off-chain. So
Yeah.
on-chain, then posting an ask or a bid or a deal does cost some to run that transaction. So to update the ask or bid, they would have to. So for example, if a miner has an asking price for all their storage, they only have to put in one bid or maybe a couple. And if they want to change that price, then they do have to pay some gas. If we are talking about off-chain, that's not the case. So we have some working designs for how to do this off-chain. We'll see whether that lands in the first version. Right now, as we're headed, it'll at least ship initially with just on-chain. But the goal is long-term to move to off-chain. So you should be able to, in the long term, have changed those bids and asks entirely off-chain without paying those additional fees. What you might need to do, though, is lock up money with payment channels. So payment channels will have to be there, or a payment channel network will have to be there in order to move to secure those funds, right? So ultimately, the bid has to lock up funds. And so either that happens on-chain or it happens in a payment channel.
Cool, thanks.
Other questions? Anyone?
Oh.
Anyone? Oh, yep.
So it was mentioned in that video that the people holding onto the files will be tested to make sure that they still have them.
Yeah.
Can you elaborate more on that process?
I cannot elaborate in enough detail here. I will refer you to the Filecoin paper or to people around here that can describe that. The succinct version, but it will only it'll only bring up more questions for you, is that happens through the proof of spacetime, and it's a process that's ongoing with all miners, and it's part of consensus. So that probably did not answer any of your questions, but it at least gave you hints to go and then find other people to ask them. And I would be happy to answer. It's just, it's a lengthier, to walk you through all of those details. The paper does a pretty good job of describing that. Other questions? Otherwise, we're going to move on because I'm taking too much time.
Last one.
There.
Super quick, this is a little abstract, but if in 5 or 10 years there's a whole lot more memory, how will that impact the market for sharing memory? If I can store a petabyte locally.
Yeah, so that plays into how we're designing things very well. Because you should, and that's not just a question around how much you store, but that's also a question of how you transfer what you can store. So moving large amounts of data is way more expensive than storing large amounts of data. So in that video you saw, in the third demo, I give this hint of you can have directly in protocol through the internet ways of distributing files or some out-of-band channel to distribute things through another channel. And so that means people could be sending data to each other by sending hard drives to each other. And so that's Filecoin is designed with that in mind. So yeah, does that kind of answer it? Okay, great. I think that's it for me. And I think I burned 10 more minutes than I should have. But that's fine. We're going to deal with it. And I think next up we have Colin talking about mining communities in China.